I'm Jeremiah Wilton. I'm a senior principal engineer in AWS databases. I focus mostly on RDS and Aurora, but I also sort of dabble in some of the other databases. I've worked on building various features for AWS databases over the years, including performance insights and DevOps Guru for RDS, as well as the DMS replication service. I've worked for Amazon off and on since 1997. I've been working on Amazon's databases for a long time. So that's me.
Hi, I'm Amit Megiddo. In '97, I finished middle school, I think. So Amit Megiddo, I've been in the cybersecurity field for about 20 years now. The past 5 years leading product management for Amazon GuardDuty, threat detection service. And one of my favorite things to do in this role is work with people like Jeremiah that are domain experts in diverse fields like databases in this case, and combine that with our security expertise to deliver security value to our customers.
Cool. At least you didn't say that thing that a lot of the new engineers say, which is, oh, on your Amazon start date, I wasn't born yet.
Yeah, no, it's...
So that, I feel slightly better. So we're going to talk a little bit about security today and databases. And I wanted to talk first about cloud security in general and what's sort of important in that. You know, we worry a lot about protecting our compute resources, EC2, our network, our applications. These are all important things. But when you look at what are your assets in the cloud, your data is really what you put there to keep safe. And it's probably the most sensitive and vulnerable digital asset most organizations have. So that's why database practitioners and managers and just folks working on the cloud in general see security as a pretty important job, maybe job zero, their number one highest priority concern, maybe more important than scalability, availability, or even performance. Because without that security, you can literally lose it all. And at AWS, we also regard security as super important, as job zero for us as well on behalf of our customers. And we've built that security in from the ground up. So when a database runs on AWS, it benefits from AWS's highly secure physical infrastructure, the protection of your own account and roles on top of that, and then also the ability to run inside your own VPC, virtual private cloud. And then finally, the ability to lock down ingress and egress to your resources using security groups. But even with all those layers of protection, speaking with our customers, they've asked for our security solutions to be more database intelligent, more specific to the database, the risks that databases face in the cloud. And I'll just sort of throw out the observation that a lot of AWS's database products are based on third-party software. For instance, MySQL, Postgres, MariaDB, Oracle SQL Server. All these different databases offer their own unique set of security features and capabilities that require customers to develop some kind of expertise in each one of those. But just like with what we did with performance insights, for instance, we wanted to simplify security monitoring across all these different database types that I just named, and provide our customers with some sort of unified and consistent approach to working with security vulnerabilities in databases across the board. And we realized that even though each of these database products are pretty unique, they all share certain properties, certain classes of telemetry, monitoring telemetry that we can observe. And the particular properties, these particular types of telemetry give us an opportunity to detect security issues in a way that is going to be pretty much common to all the different relational database types. So we decided to set about building a way to do that, to detect the most serious types of database exploits so that we can alert customers when something something is happening so that customers can stop those attempts. So let's talk about how databases might be sort of considered special from a security standpoint. Well, in a typical application architecture, access to the database usually comes from several application servers, right? And a lot of times, customers set this up with a single read-write login credential, like a single username that that application uses to log into the database. So an attacker who compromises an application server may find a way to access the database. Or you might have some other types of software running in your VPC, like LDAP, or some other kind of widely known and recognized package that maybe like earlier versions of it have some kind of known vulnerabilities. Bad actors can use these kinds of open source and third-party software products as a springboard for attacking a database, sometimes by brute force. And keep in mind, bad actors come in a variety of shapes and sizes. Databases are not just a target for external parties, but also for insiders. So anything that we were going to build to detect threats for databases, we thought really should be able to identify both insider and external threats. We also realize that our customers aren't perfect. Some of our customers don't always perfectly configure their systems, their accounts, and their security groups perfectly from a security standpoint from day one. Sometimes they leave their databases vulnerable to the outside world, which unfortunately invites scanning and other types of attacks. So database security really needs to be tuned to detect these specific kinds of attacks that databases are often subject to. Now, I'm sure everyone here is perfect, that you perfectly configure all of your resources in all of your accounts. And hopefully you do that using the tools that we make available to you in AWS. But I'm just going to sort of underscore what we hope that our customers will do and recommend a few best practices to make sure that you have the best possible database security posture. So first and foremost, I think one of the first things that we would recommend is don't configure your security groups to expose your database to the outside world. Right? All the resources that interact with your database should ideally be connecting from within the same VPC. And another thing to really maybe be thoughtful about is how you set up your database credentials and usernames inside the database. It's a good idea to create a separate user or role for each application that accesses the database, so that each user or role is configured with the minimum necessary privileges and access rights to do its work for that specific application that it's assigned to. Some databases even let you restrict specific roles so that they can only log into the database from specific hosts. That way, you can restrict which application server pools are able to access specific database roles. The next thing to do is to make sure you rotate your keys and passwords regularly. And when it's necessary for a human to be performing operational maintenance tasks and troubleshooting on your database, make sure that they use temporary credentials that expire automatically. Don't stay active forever. All the major database types allow you to generate an audit log of activity. That includes information like the connections that are being made to the database, the queries that are being run on it, and what kinds of modifications are happening to the database. At a minimum, organizations should be regularly reviewing a sample of their audit logs in order to establish whether any kinds of patterns of misuse might exist. But these are all just a few sound security practices that I wanted to convey. Many of you already have in place sound security practices within your organizations. But fortunately, we don't leave it all up to you. AWS also offers a service for protecting your AWS resources beyond just these best practices. And I'll ask Amit to tell you a little bit about it.
Sure. Thanks, Jeremiah. So Jeremiah mentioned, by the way, the misconfigurations leaving, this case, perhaps databases exposed to the internet and the scanners out there. We see that day in and day out with what we see from GuardDuty here from customers. Just as an example, not from RDS, from EKS, where GuardDuty monitors audit logs, about a second, if not less, for a misconfigured cluster to be scanned, both by good guys and bad guys out there. Within minutes, secrets, Kubernetes-specific APIs retrieving secrets, and within hours, that spinning up new pods and crypto mining. So the threats are real, and we see them, and that's why we developed GuardDuty. It was launched 5 years ago at reInvent, and quickly became a very well-adopted service, used today by tens of thousands of customers. About 85% of our top 2,000 AWS customers use GuardDuty today. But when you think about that long tail of tens of thousands of additional customers, really individual users and small companies and startups that use the service to help protect their AWS environment. How many people here, by the way, have GuardDuty enabled their environment? Okay, about 85%. So GuardDuty, one of the things that when we developed GuardDuty, we really wanted to make it easy to get a good level of security across your entire environment. We know that there's a lot of pains with operational overhead for security teams to deploy security solutions in these complex environments. Sometimes it can be dozens, hundreds, thousands of accounts. And with GuardDuty, it's really a single-click organization-wide activation. If you have 2 accounts, if you have thousands of accounts, single click and you can deploy GuardDuty everywhere. In the continuous monitoring aspect, so GuardDuty monitors different log sources, and by doing that, you don't need to configure and pick and choose specific resources you want covered, a specific instance, a specific IAM identities. By enabling GuardDuty, it continuously monitors the entire environment. And if there's a developer in some team in some part of the organization that spins up a new resource, GuardDuty will automatically monitor that as well and protect it. At the core of GuardDuty are the security analytics. A lot of investments over the past 5 years in more advanced machine learning capabilities to detect these somewhat harder to detect threats. And we're seeing real success there with GuardDuty able to detect threats and often early in attack where other more traditional detection methods can fail. And then also the threat intelligence aspect. How do we leverage our really unique and very broad visibility in GuardDuty in AWS to the entire AWS space to identify malicious IP addresses and domains of malicious actors and do so sometimes weeks before they're detected elsewhere, and allowing GuardDuty to alert you on threats earlier. And then that enterprise-wide, so it started with that single click to enable and deploy organization-wide, but then also acknowledging that there's diverse environments, then customers want to consume the output of GuardDuty, the security findings, in their existing tools and security solutions, and building GuardDuty to integrate with these diverse environments. So how does GuardDuty work? You can think of security as a big data problem, and that's the core of GuardDuty. Vast amount of data, hundreds of millions of events every minute processed by GuardDuty, and the goal is to take that big data, those hundreds of millions of events, and turn that into actionable security findings. So coming into GuardDuty are the different log sources, and part of where we're focused and looking toward continuing to expand GuardDuty's visibility. When we launched GuardDuty, it had the first 3, so the flow logs, the DNS logs, the CloudTrail. We've since expanded coverage to also help better protect data stored in S3 buckets with that S3 data plane visibility. And what I referenced earlier was that EKS audit log visibility to help protect your EKS clusters. And as we'll talk about today, now expanding to RDS as well. All that data is pushed through GuardDuty's processing engines, where we have teams of security engineers, SDEs, domain experts like Jeremiah, all coming together to develop models and detection and threat intelligence to accurately detect threats in your environment, and really focus on where we as AWS and GuardDuty can differentiate and provide unique security value, things like unique detections for instance credentials exfiltration, seeing when instance credentials not only are maybe used from outside AWS IP space, which could be a bad sign, but even within AWS, but a different account than the ones they belong to, which is a more evasive attack technique that GuardDuty can uniquely detect. And now at the other end come the security findings, and that actionable, accurate, contextual. We're really doubling down on it. And this is also where your feedback, customer feedback, is so valuable to help us get those findings really accurate. We hear customer feedback about alert fatigue and problems with staffing security teams, and some organizations that, as I mentioned, on the smaller end, maybe don't have security teams and still want to secure their environment. So how do we get those detections really down to a very accurate and actionable level and add as much context to them? And then the integration piece, GuardDuty findings are automatically pushed if you're using Amazon Detective for investigation, if you're using AWS Security Hub to consolidate findings from across your AWS environment and take action from that central place. And then through EventBridge, which is an event bus that can push findings downstream, either to an SNS topic and from there to an email to alert you on high severity findings, or to dozens of partner solutions that we hear from customers that they're using, and through this integration can easily push GuardDuty findings to these services. So with that, I'll pass it back to you, Jeremiah.
Cool, thank you. Well, now that you know more about GuardDuty, let's delve a little bit into some of the landscape that is available in the area of AWS databases. RDS, which is short for the Relational Database Service, and also Amazon Aurora, these are what we call managed database services. They're automatically managed databases that take care of all the mundane day-to-day tasks for you. The kinds of tasks I'm talking about are things like provisioning a new database, or scaling up and down, or backups, recovery, high availability, disaster recovery, upgrades, patching, and the list goes on. Basically, everything that you would be having to script yourself or having to do manually on a conventional database, that's totally automated in RDS and Aurora. And we provide in RDS and Aurora versions of all the most popular databases, both open source and commercial. Now, how about Aurora? What is so special about Aurora compared to, say, RDS MySQL or RDS Postgres? Aurora is our cloud-native database engine. We designed it to meet the needs of enterprises with more demanding requirements in terms of features, scaling, and performance. These are the kind of customers who need powerful and full-featured databases, but are maybe becoming weary of the legacy commercial databases, punitive licensing approaches, and their significant expense. And also those legacy database products' lack of cloud-native capabilities. So Aurora is our answer to that customer need. At the SQL prompt, Aurora looks and feels exactly like Postgres or MySQL, but behind the scenes, it features a distributed, a fault-tolerant, and self-healing storage system that automatically scales up to 128 terabytes per database. Every single Aurora cluster replicates automatically across 3 availability zones for durability, and at the same time delivers high performance and availability with the ability to add up to 15 low-latency read replicas. So in essence, Aurora is a cloud-native, massively scalable and available database that seeks to address high-end enterprise use cases in a way that MySQL and Postgres, out of the box, can't necessarily do. And Aurora aims to do that at a lower cost to our customers than those legacy commercial databases. With Aurora and RDS, our direction has been to continually add more and more automation features to further reduce the need for customers to do anything manually, and also to lower the expertise bar and make our databases more usable and more manageable for IT generalists. In 2016, we released Performance Insights, which is a new way of visualizing and monitoring database performance. It offers a single common user experience based on a single common derived profiling metric called database load. And it uses that same approach, experience, and metric across all the database products in RDS and Aurora to create a consistent tuning experience for our customers across all those different types of databases. Then in 2021, we released DevOps Guru for RDS, which uses machine learning on that same data to detect, analyze, and recommend resolutions for database performance issues. So as you can see, our direction in RDS has been to further offload labor and toil from our customers and to automatically detect and resolve various types of problems. And I'll just add to that, database security, job 0, is no exception to that rule. So when we think about database security, there are a number of different levels we can think about it on. Because Aurora includes the best of MySQL and Postgres, it offers those database products native security features like encryption, TLS, transport layer security, auditing, password lifecycle management, external authentication, and everything else that comes with those databases. On top of that, Aurora provides additional capabilities like IAM authentication and database activity streams, which lets you monitor your database's audit log using popular third-party database activity monitoring packages. And at the AWS level, there are even more features like VPC and IAM and database and security groups. But these are a lot of different choices and options. And we're all about bringing ease and clarity to our customers. And we felt like security was an area that was an opportunity for us to give a helping hand to our customers in the database area. We felt like we should be building automation to monitor database security, to detect issues automatically and give advice so that you don't have to be a database security expert. And we want to bring that same unified and automated approach to security as we did for performance and operations.
And that is why we're introducing Amazon GuardDuty RDS protection. So this is the latest expansion of GuardDuty to help you better protect your RDS databases, starting with Amazon Aurora, by identifying suspicious logins to your databases. And we really found that looking at that initial point of the login to the database is a data set that we can work with and identify an early stage of access to the database that can then escalate to threats to your data and detect it when it can be mitigated. With a single click, again, the same GuardDuty experience, single click, you don't have to configure any logging or set up any permissions or make any changes, configuration changes to your databases. Just go to GuardDuty, single click, and GuardDuty begins, whether it's a single account or thousands of account organization-wide, will begin monitoring all existing RDS Aurora databases. Any new database that someone spins up tomorrow, automatically protected, monitored, profiled by GuardDuty. And then applying machine learning techniques that we developed closely together with the RDS team to really wean out the signal from the noise and make sure that we're able, on the one hand, to detect threats and do so with as little noise around as possible to allow you to take action. So back to this how does it work slide. So along each step of the way of the GuardDuty process, there's now new capabilities. First, on the visibility side to the data sources, so the Amazon Aurora login events. And as mentioned, another data sources that on the back end can be immediately consumed by GuardDuty across your entire organization and begin monitoring this new log type in GuardDuty. The security analytics part is key. That's maybe where the magic happens. I don't think we've ever collaborated so closely with the service team as we have with RDS over working on this feature, and really bring together the GuardDuty team security expertise, our joint data science teams, data science expertise, the RDS database expertise, and in addition to that, our really broad visibility to cloud databases in the cloud and activity around them, to develop tailored machine learning models that are trained to detect threats and highly suspicious logins to your databases. And each one of these goes through a long iterative process. Literally, there's a joint team from all the different teams I mentioned that meets weekly for weeks, for months, to analyze these models, their output, iterate them, and repeat until we get to a point today where we launch this for customers. And then the security findings out the other end, new GuardDuty security findings, really giving you that context you need to answer questions like, what was unusual about this login activity? Has this user ever accessed this database? Has this database ever been accessed from this location? And quickly understand, why did GuardDuty flag this? And is this something that we should put in a queue for investigation, or we should raise the alarm and action on immediately? And then, seeing as this is an expansion of GuardDuty, and for those that are already using GuardDuty, you don't need to set up additional integrations and operationalizations. If you already have GuardDuty flowing down to your security systems, to your alerting, workflow, tooling, these are just new GuardDuty findings that will automatically be consumed downstream like the existing ones. Is that you?
Yeah, I got it. All right, so let's talk a little bit about how the database GuardDuty RDS protection works. So when you create an Aurora cluster with GuardDuty protection enabled, or when you enable GuardDuty protection on an existing Aurora cluster, Aurora begins collecting and streaming the details of your incoming connections. GuardDuty RDS protection ingests these details and sends them on to be processed to detect any kind of suspicious activity. If it detects an issue, it passes all the details on to the main GuardDuty service, where the findings are made available in the same way that other GuardDuty findings are presented. These findings give detailed information on the severity of the threat, the time frame, the database involved, the username, the ASN of the connection, and the application involved, and what kind of attack GuardDuty thinks that it might be. With these details in hand, a customer can quickly take action to address the issue at the database or AWS level by terminating the connection, changing passwords or security configurations, or any other responses that they deem appropriate. Now, I want to give you an additional look inside this new feature so that you can understand how it does the threat detection. Maybe you feel like in that last slide I sort of glossed over this part where we detect suspicious activity. What do we think is suspicious? How do we know it's suspicious? Well, if you've ever had a good look at a database connection log, you can see it's not exactly an easily understood or parsed set of data.
Looks suspicious to me.
Looks suspicious?
Yeah.
Okay, yeah. Maybe there's something in there. Well, this is what a raw log looks like. And like I said, it's a little dense for visual examination, so I created a little cleaned up version that is maybe a little bit easier to look at. The connection log contains an entry for every connection the database handles. And it's recording things like the username, the driver or client that is being used to make the connection, the IP address, database it's connecting to, the connection type in terms of like SSL or TLS, and the success or failure code. Like did it connect successfully, exit code 0, or did it fail in some other kind of exit code that indicates something else? It's a lot of detailed, interesting information, except that usually it's actually not interesting at all. And the reason it's not interesting at all is because almost every line in this log looks just like the line before it and the line before that one. So looking at these logs, it's really obvious when there's an entry that doesn't look like the others. Maybe it's a weird IP address that normally never connects to this database. Maybe it's a user or a database schema other than the standard application user or database schema that is used. Maybe the success or failure code is one that means that the wrong password was attempted. In any case, all these different oddities really stand out, and we can even notice that a connection with multiple unusual attributes is possibly even more suspect than one with just one unusual attribute. For that matter, many unusual connection attempts of a certain type, such as login failures from an unfamiliar IP address, could indicate something like a brute force attack. So it struck us, looking at logs like this, that the nature of these anomalous log entries could be used to detect specific types of attacks and exploits happening to a database. And we thought it would be really useful for our customers if we built something that detected these oddities and generated useful and descriptive findings about them. So the Aurora team added lightweight connection logging capabilities to Aurora, very much like what you see here in this sample log. And the team in RDS that builds operational management features teamed up with the folks on the GuardDuty team, and then using ML, as well as our many years of knowledge of threat detection and attack profiling, we built a system to process connection logging data in real time, detect and classify potential attacks, and generate database-specific GuardDuty findings for GuardDuty customers that have Aurora databases. In other words, GuardDuty and RDS teamed up to make GuardDuty database intelligent.
If I can, Jeremiah, I think this is a great example where, and we've learned this from 5 years of GuardDuty and customer feedback, rules work well to detect when something unusual happens, but they don't work well at scale and when it comes to noise. So it's not just a matter of, okay, let's build a rule and look at all the previous IPs we saw, and have we not seen this IP access this login to this database before. But it's rather using machine learning techniques and models to also that intelligently ask the question, okay, but is it expected for this IP? Maybe this database is usually accessed by many new IPs regularly, and we can learn that and still identify when there's that odd case that does pass the threshold for an ML model. Rules they're good at true positive and avoiding false negatives, but they're too noisy, and that's some of the learnings we applied here as well.
Yeah, indeed. Right, like balancing alerting a customer to something that our models think is important with alerting our customer about a bunch of really common scenarios that might typically occur. We really need to do a good job of balancing that. And as somebody who's worked with databases for a long time, I don't mind hearing a few false positives. But I don't want it to ruin my day, and I don't want it to wake me up every night at 2 a.m. And so making a really, really well-tuned ML model that is able to baseline these different scenarios, like you said, the distribution of unusual IP addresses for a given database, it allows us with ML to not create a static rule that is a one-size-fits-all for what inevitably are really different databases around the world. It allows us to make models that look at the database, understand its uniqueness from the perspective of what are the properties of typical connections to that database, and then understand what is unusual happening to that specific database. So during our initial testing, we actually used our internal red team, our database security experts, that craft representative database attacks against our services. And GuardDuty RDS protection was able to detect all of their attack vectors. In one case, the team attempted to gain access to one of our test databases by making many, many rapid connection attempts to the database, trying thousands of passwords based both on dictionary and algorithmic permutations. And GuardDuty detected and accurately classified that one. In another test, GuardDuty RDS protection detected when our red team simulated the scenario of misused credentials, where the password was correct on the first try, but the other aspects of the connection, like the client application and the client IP address, were off. They were atypical. Scanning is another issue we want to help customers detect. Our testing showed, go back one. Scanning is another issue that we wanted to help customers detect. Our testing showed that GuardDuty RDS protection was able to find cases when default roles like root were being tried from IP addresses outside of a customer's VPC. In all these different scenarios, GuardDuty RDS protection was able to detect whether the connection attempts were successful or unsuccessful, which is an important thing that you need to know looking at that.
Yeah, and Jeremiah gave the examples of our red team tests. But we run this before we launch these type of things publicly, we run them extensively internally in beta environments with beta customers, and we've seen real success here. We've seen GuardDuty accurately detect databases that are sort of on the brink of being compromised or actually have malicious access already. And then the findings on the other end, Jeremiah touched upon this, but giving that context, so the finding name itself indicating, did GuardDuty detect an unusual successful login or an unusual unsuccessful login or failed login attempt, differentiating the severity between the two, but in both cases, something that should be actioned on. That section in the finding that points to what was unusual about the activity. Additional learnings from 5 years of GuardDuty, maybe intuitive, is that telling a security team or a consumer for GuardDuty finding, hey, something anomalous happened, good luck, is a sure way to lose trust, waste people's time, and send them and not allow them to prioritize accurately. So now GuardDuty anomaly findings, the existing ones we already do with the CloudTrail and the S3 data plane and EKS, provide that context, and we carried this into the RDS use case as well. So we'll not only tell you, hey, something unusual, there was an unusual login to your database, but what was unusual about it? What was the expected behavior for this database, for this user? The resource section providing all the details on the database name, the username, the application. And then the actor details, taking that IP address and attributing it geographically to the ASN, and as well as GuardDuty threat intelligence. I think back to you, Jeremiah.
Yeah. Well, let's talk about what happens if GuardDuty RDS protection detects an issue. What should you do? Well, depending on the nature of the finding, it will provide recommendations for addressing the concern. For instance, if it tells you that connection attempts are coming from an unusual IP address range, it might advise you to tighten your security group posture in order to prevent unauthorized hosts from connecting, especially those outside your VPC. If GuardDuty RDS protection detects a user that you don't recognize and detects that it's connected to the system, to the root database or the system database, it might advise you to terminate that connection at the database and rotate the credential that was used in order to prevent further connections. And whenever GuardDuty RDS protection detects unusual activity, it's a great opportunity for you or your security team to review database audit records and determine if the issue is part of a larger pattern of misuse or abuse.
That worked. So getting started with this new capability, as I mentioned, it's part of GuardDuty. So I'm now here in my US West 2 GuardDuty account. If you log in to one of the 5 regions that are supported during the public preview period, so that's US East 1, US East 2, US West 2, Europe, Ireland, and Asia Pacific, Tokyo, then you will see this message about the new feature. As I mentioned, available in multiple regions. So I'll go now to US East 1. I see the new RDS protection here on the left hand. And if I go here, I can see I can enable it for my account. Or in my case, as we can see here, I'm a GuardDuty administrator, delegated administrator for the organization, and I'm monitoring or managing GuardDuty for 16 accounts in my organization. And here with that single click, RDS protection is now enabled for all 16 accounts, all existing Aurora databases, any new database launched, automatically profiled and monitored by GuardDuty. This did 2 things. It enabled RDS protection for all 16 of my existing accounts. But if later tonight I decide to set up a new account in my organization, then GuardDuty RDS protection will be automatically enabled on that account as well. And then also here through the accounts page itself, I can see now all these nice green check marks for RDS protection. And I can also choose to manage it at the individual account level. But really, that's not recommended, and getting that org-wide visibility is the best way to go. In the findings, so another GuardDuty, you can generate sample findings. And what that does is generate 1 copy of each GuardDuty finding type, which I now have here. I can filter this by resource type. See, there's a new resource type for RDS DB instance. If I filter by that, then I see the 2 current 2 new GuardDuty finding types, the sample finding of those in GuardDuty. This is useful for before you get an actual finding, which hopefully you won't. But before doing that, you can see a sample of the new finding types. You can see the JSON version of the finding, and use that if you have automation that leverages any of the fields in the finding, and just to familiarize yourself or to set up that downstream integration using the new specific finding schema for these RDS finding types. And back here, yes.
Awesome. So just to sort of clear up a few maybe uncertainties around this new announcement, I wanted to ask you a few things sort of on behalf of our customers and things that I'm curious about as well. So if I am a GuardDuty customer, how can I get started with GuardDuty RDS protection? What do I have to do?
Yeah, so we just saw that in the demo. But really, if you log into your GuardDuty console, then in one of those 5 regions, just click those buttons that I just clicked, enable it for the account, enable it for the organization. During the public preview, only through the console. When we get to GA, then also through the API, CLI, and CloudFormation, if you so choose. I will mention that GuardDuty is regional, so you would need to enable it in each of the specific regions in order to get that visibility in each region. So enabling it in just one of the regions will not give the visibility to the other ones.
Right. So, and if I'm a new user of GuardDuty, do I have to also go in and then manually enable RDS protection in my account, or is it enabled by default for my accounts?
So if you're already using GuardDuty, you go through the steps that we just saw. If you're not using GuardDuty yet and you enable GuardDuty for the first time, GuardDuty automatically enables all the protection plans to get that maximum level of visibility, including the new RDS protection. So if you enable GuardDuty for the first time in one of those regions during the preview, GuardDuty RDS protection will be enabled. And you can then choose to disable it or opt out if you so choose, but by default it will be on.
Okay. And can I get it a la carte? Can I enable RDS protection without signing up for GuardDuty?
So when you enable GuardDuty for the first time, it comes the existing. I think there's a question coming on that, but during the preview, this is all free. But for the existing GuardDuty, it comes with a 30-day free trial, and there's that base level of security of protection that by enabling GuardDuty is best practice to have on, monitoring the instance level behavior and the account IAM entity level behavior. So that's part of base GuardDuty when you enable it. And then there's the new protection plans that you can opt in or opt out. So you need the base GuardDuty on, and then you can enable the RDS protection as well.
And when I enable this for RDS protection, do I have to enable it one Aurora cluster at a time, or does it turn on for all the Aurora clusters in my account?
Yeah, no, it's automatically all Aurora, supported Aurora clusters, any new Aurora cluster. We really want to avoid, and we're avoiding GuardDuty, that resource level configuration that just results in operational overhead and coverage gaps, security coverage gaps. There's no reason to differentiate between databases and to put that onus on the security team to start having to choose which database do you want protected or not.
Cool. And during your demo, you showed the different regions that this is available in. Is that a subset of the regions that GuardDuty itself is available in during the preview?
So GuardDuty itself, the existing GA features in GuardDuty are available in all AWS commercial regions, in the China regions, in the 2 US GovCloud regions. During the public preview, this feature for RDS protection, as mentioned, is in US East 1 and 2, so North Virginia and Ohio, US West 2, Oregon, Europe, Ireland, and Asia Pacific, Tokyo are the 5 regions for the preview. When we get to GA, we'll expand across regions according to as GuardDuty is available today.
Okay. And another thing I think that some customers might want to know is the difference between a public preview and GA. So this feature, RDS protection, is in public preview right now. What does that mean versus a GA feature?
Yeah, so there's still some capabilities that are not available during the preview, and that's why we're in preview and not GA. So I mentioned the API or CLI and CloudFormation support, the region, the lack of complete region availability. There's some decoration of findings to the findings that we're going to add more enrichment of the IP address that the login activity originated from, additional context on the expected behavior for the entity, for the database. So there's more features we're working on that to get to that what we consider GA-ready GuardDuty bar. But really, this works. Like we both saw it work over the past weeks, over the past month. We have solid detection capabilities, and really I recommend, as I mentioned, free during the public preview. I really recommend to enable it. You'll get a layer of security protection to your databases that, even though it's in preview, already provides real security value. On that note, we're also, even after GA, and we don't release GuardDuty detections and throw them out to the wild and they never touch them again. We continue to iterate them, even more so during this public preview period. We'll be looking for your feedback to continue. We're going to continue those weekly meetings that I enjoy, to continue iterating on customer feedback, more broad customer feedback now, to get those models even more accurate and get that signal to noise ratio even better.
That's great. Well, that's all my questions. And so I guess I will turn it over to our audience and open up the floor to any questions. And if you have questions, either go over to the microphone or speak loudly so I can repeat your question.